Welcome back. This is lesson 13.1, Patterns in Data Journal. I will be able to identify patterns within data distributions by analyzing dot plots and histograms. I will be able to use those distributions to make accurate predictions and generalizations about the data. So you're going to be able to look at these different patterns and make good ideas about the data in general. So you also will need the Chapter 13 vocabulary page. Okay, we've got quite a bit of definitions to fill out today. So data is a collection of facts, such as attributes, words, measurements, or observations. A cluster is when data seems to be, clustered within a certain set of numbers or values. Let's say values. So looking at this data set, you see how most of the dots are actually located right around here. So I could say that there is a cluster between 1 and 4. I probably could say 0 and 5, but just having 1 isn't really clustered together, whereas these are all, most of the data is found right there within that circle. Okay, a gap is where is an interval of the data set where there are no data values. So looking at that, between 8 and 10 is considered a gap here. There's no data from 8 to 10. Okay, the peak is the highest frequency point on the data distribution. This is usually your mode. So where's the highest data set here? Well, that would be 2. So the peak here would be 2. Okay, pretty easy. Now skewed is when most of the data is located on one side of the data display. And this is usually because of an outlier. Now looking at this, see all these different bars here? You see how there's lots here, and it just kind of gets lower and lower and lower? Well, most of the data is over here on the left. Skewed is the part that has less data. So this would be considered skewed to the right. Because this right side is really low compared to the left side. Well, if that's the case, this side right here is really low. This would be considered skewed to the left. Okay, symmetrical is when the data distribution mirrors itself. So here's an example. They're all the same. But if I were to put a line of reflection down this side, it would be a mirror. Same thing here. If I were to make a dotted line here, you see how that makes a mirror on both sides? Okay, here could be another one. So those are all considered symmetrical data distributions. All right, that's all we need to do for today. So go ahead and put that aside. Now let's look at this set of data. This is the average daily temperatures And where do we see a peak? Where's the highest on this one? It looks like this one has the most. So the peak here would be 64 degrees. So what does the peak mean in this situation? It means there were more days at 64 degrees than any other day, than any other temperature. Okay, do we see any gaps? I see a gap from 56 to 58. There's nothing there. There's also a gap at 66. So what do the gaps represent in this situation? There were no days with a high temperature of 56, 57, 58, or 66 degrees. All right, clusters. What do we see for a cluster? To me, it looks like most of the data is found right here. We could probably count this guy in there too. So our cluster we see between 59 and 65. What does this mean? Well, since we're talking about average daily temperature, it means that most days were between 59 to 65 degrees. Okay, is this data skewed or symmetrical? In this case, I don't see, it's not really symmetrical. It doesn't really mirror. I do have a cluster here in the middle, but it's not all the way to the right or all the way to the left. So I'd say neither. It doesn't mirror. And most data are in the middle. All right, explain what patterns you see in this data and what it means in this situation. So we're talking about this one right here. So looking at students' shoe size, we have 6, 7, 8, 9, and 10. Well, it looks like we have lots in the 6, 7, and 8 range, not very many in the 9 or the 10. So what patterns do we see? I see a peak at 7. No gaps. And it's kind of clustered around 6 or 8. So what does it mean? It also looks to me like most of the data is on the left side, so that means it's skewed to the right. So what does this mean? Most students, here's our generalization. Most students wear size 6 to 8 shoes with just a few in the 9 to 10 range. See, that's how looking at a data display, you can make generalizations. Now, if I were to be a shoe salesman for students this age, I'm probably going to stock more shoes in the size 6, 7s, and 8s than I am in the 9s and 10s, because if I just bought the same amount of every shoe size, I'm probably going to end up with a lot of size 10s hanging around because there's not as many people that need the size 10s. So that is how you could use this data, depending on what you're doing, to make generalizations and apply it to real life. All right, let's look at this one. What are we comparing? Frequency, miles per gallon. Miles per gallon is how much gas a car burn, or how far a car can go on a gallon of gas. So looking at this kind of looks symmetrical. It's not perfect, but it's fairly symmetrical. So this looks fairly symmetrical. It's not perfect, but it kind of mirrors. I have a gap from 0 to 5, which means we have no cars that go less than 5 miles for 1 gallon of gas. That's good. That would kill your pocketbook. If it costs you 1 gallon of gas just to go 4 miles, you couldn't even drive it halfway across town without using up a gallon. Okay, what else do we have here? Looks like we have a peak between 15 and 20. What else do we have? Okay, it's not skewed. So what generalizations can we make from this? No cars have miles per gallon less than 5. And it looks like the average because you can see this center area, the average is around 15 to 20. And maybe a few more, maybe slightly more, have better than 20 than less than 20. So we can see here 20 had it here, 15 here. This one had 25 and 15. So there's just a slight better up here than there is down here. But that's how you can make generalizations.